Okay, so it says if f of x is a third degree polynomial function, how many distinct complex roots are possible? Okay, so let's read what they're trying to say. So it says, given that f of x is a polynomial of third degree and we need to find the distinct complex roots of it, an expression of the form axn plus an minus 1 xn minus 1 plus a1x plus a naught, where ai's belong to a real number for 0, so I between 0 to n, is called a polynomial. So this is right. And we know that the complex root of such a polynomial expression always occurs in pairs. That means the roots are complex conjugates of each other. If a plus ib is a root, then a minus ib will also be a root of it. So this is right. Two cases are possible. All the roots are real, then there are no complex roots. The second point being there are exactly two distinct complex roots, hence the answer is either 0 or 2. Okay, so because this question is very I mean, it's not really a skill question. They're not testing you to look at a third degree polynomial function and trying to identify what the distinct complex roots are from that polynomial function, right? So this is very it's just asking you a general question, right? So when they mean that two cases are possible, which is right. So say, for example, all the roots are real, then there are no complex roots, meaning you can't really factor. You don't have any zeros. That's what they're trying to say. You don't have any zeros. It's basically x cubed, right? So on and so forth. There's no factor, right? That's when they're trying to say there are no complex roots. The second point being there are exactly two distinct complex roots. So in that case, you would have, so this is just me giving you an example just to further illustrate that, because it's very it's a very general question. So when they're trying to allude to the second point, let's say you have x minus 5, right? And then this is basically multiplied to x squared plus 4, right? So as you can see, going back to the question, there are exactly two distinct complex roots, right? Therefore, this is going to be x minus 5 and x squared plus 4, because this is a root, right? And this one you can't really further simplify, right? There's no way you can simplify x squared plus 4, so that there's two roots. And then if you have an imaginary number, which I think they also brought up, it says, and we know that the complex root of such polynomial expression always occurs in pairs. That means the roots are complex conjugates of each other, and then so on and so forth. They presented a plus bi is a root, then you have a minus bi will also be a root of it. So when they're trying to say that, right, you can actually expand this and say, okay, you have x minus 5, and then basically this is going to be x minus 2i. So the only way for you to factor this is to have imaginary numbers. So x minus 2i, and this is basically x plus 2i, right? So this is the conjugates, right, of each other, because it's minus and this is plus. That's what they mean by conjugates. Okay, so let's go back to the question again. Yeah, so it's right. I don't have anything to say. They pretty much answered the question, but give examples, I would say. So let's see. So the solutions and the answer is right. However, since this is a very general question, providing an example for the two cases will be appreciated. And okay, no, not will be appreciated, will be easily understood. Yeah, that's what I wanted to say. Seen and understood. Okay, great. Solution is correct.